All right. Is everyone ready?
Yes.
Okay. Hello, I'm Chris Barrett from Cornell University, and I'm the moderator of the full scientific session, Interdependence of Human Health, Livelihoods, and Aquatic Social Ecological Systems. Thank you for joining us. This presentation is one of 3 pre-recorded videos focusing on a speaker's material before all the panelists come together in February during the live discussion. In this video, Professor Giulio of Stanford University will be discussing ecological solutions for the control of parasitic diseases of poverty. Midway through the video, Professor Chirstina Hicks from Lancaster University will be joining Giulio to further delve into the material. Giulio, we look forward to hearing your talk.
Thank you very much for the introduction, Chris. I'm honored to be here and to share with you all, a part of our research. I'm Italian, I'm a disease ecologist, and I've dedicated my professional career to investigate couple natural and human systems and to discover novel ecological solutions for all diseases that have afflicted humanity for centuries and longer. Today, I want to talk to you about the nexus between agricultural expansion, the development of water management infrastructure, and waterborne diseases. By the end of this century, the United Nations projected the global population will exceed 11 billion people. And meeting the UN Sustainable Development Goals to eradicate hunger for this growing human population will necessitate a large increase in food supplies with major changes to agricultural production. The goal of increasing agricultural production will be challenged by increased risk of droughts and water shortages associated with ongoing climate change. And to face these challenges, it is crucial to develop water management infrastructure, irrigation schemes, and in particular, dams. Dams and the increased agricultural productions will definitely improve human health by reducing food prices and enhancing nutrition, which increases health by boosting resistance to infectious diseases. However, the construction of dams and development of irrigation systems, along with the use of agriculture and agrochemicals, will increase freshwater habitat, which in turn increase the risk of waterborne diseases, such as schistosomiasis. To show how this can happen, today I want to bring you in a little journey with me to our field sites in the lower basin of the Senegal River at the border with Mauritania. Here, following 2 decades of drought and increasing risk of saltwater intrusion, 4 countries, Senegal, Mauritania, Mali, and Guinea, get together and decided to build the Diama Dam, which was completed in 1986. A year later, the first few cases of intestinal and urinary schistosomiasis were reported by the local health authority. The onset of what is probably one of the most spectacular outbreaks of schistosomiasis in modern times, which made the lower basin of the Senegal River one of the most hyperendemic places for schistosomiasis in the world. Schistosomiasis is a parasitic disease of poverty. It affects more than 240 million people worldwide, the vast majority in sub-Saharan Africa, especially school-age children. With 800 million people at risk, it's one of the most important of the so-called neglected tropical diseases. One very important component of this system of this disease is that the parasites require 2 hosts to complete the life cycle, the human host and specific families of freshwater snails. And the parasites need to go from people to the snails, back to people through a couple of free-living stages. So people get infected by stepping into schistosomiasis contaminated water. In this video of one of our field sites in Malatak in the lower basin of the Senegal River, you can see the typical habitat of these tiny freshwater snails. These are the patches of floating vegetation, and these here are the ecotone, the border between the emergent vegetation and the open water. To fully appreciate what are the implications of these major irrigation systems, I prepare for you a footage of how the landscape has dramatically changed since the construction of the Diama Dam. This is a collage of Landsat images covering more than 20 years from 1984 to 2012. And you can see the expansions of all the agricultural area. And to make this long story simple, basically, and boil down to the essence, what actually happened is that more water basically lead to better habitat for the snails that amplify the disease. So it leads to more snails and eventually to more disease. There are things you can't see from satellite imagery. And one of them, which is actually very important, is this guy here. It's called Macrobrachium volenovi, and it's a native freshwater prawn. It happened to be a voracious predator of the snails that amplifies schistosomiasis. And the interesting thing is that when it eats the snail, it does not get infected with schistosoma parasites. So it's a perfect agent of biological control. It's what we call a natural enemy of schistosomiasis. Now, one very important peculiar aspect about these freshwater prawns is that it's a migratory species that require brackish water at the estuary, so a little bit of salty water for reproductions. And then in a year is able to crawl and swim upstream up to 1,000 kilometers and basically, occupy all its niche. Now you can see that the construction of the Diama Dam built up an impassable barrier for these prawns basically to swim upstream. And so this basically agent of top-down biological control of the snails has been completely extirpated above the dam. So the combination of better habitat and no predator created the perfect storm for the outbreak of schistosomiasis. These differences, dramatic differences, landscape, as you can see here, 1985 and 1999, comes along with a series of cascading consequences. We saw more water, more vegetation, more snail, more disease, also extirpation of prawns, which lead to even more snails and even more disease, and a number of other cascading consequences, more agriculture, which is per se is very good, but also more agrochemicals, which impact again on prawns, and also more people, which altogether lead to more disease. We've been describing this set of linkages in a publication led by Jason Rohr with Chris Barrett on Nature Sustainability last year, which described the full set of potential implications. Now, this is a big problem, but another element which is important is basically to understand whether we can transform this problem also in an opportunity. So this led us to the research question whether we can control disease transmission by restoring the lost snail's predator. So in 16 villages, we built up enclosures and stock prawns, in addition to the traditional medical intervention through basically chemotherapy treatment by using Prozaquantal, the drug of choice of schistosomiasis. And again, to make this long story short, we have been shown that the combination basically of medical interventions with environmental interventions, so the stocking, restocking prawns, recovery the population, will lead to fewer snails and to less disease. We've been using also modeling approach to show that the combination of mass drug administration or chemotherapy interventions with environmental control of the disease is actually much more cost effective than MDA alone, and might lead to permanent extirpation of the pathogen from the water body, with greater efficiency and improvement in the livelihood. There is more to say about that though. I mean, this prawn is not only a powerful agent of biological control, but is also a delicious food that would happen to be part of the diet of the local population before it was extirpated in the upper part of the Diama Dam. So along with Chris Hoover, a candidate PhD student at UC Berkeley, and Justin Rimes, we've been working on modeling basically the effect of prawn aquaculture to control disease, especially in rice paddies. So we've been basically developed a bioeconomic analysis in which we've been describing somatic growth of the prawn, the dynamics of their abundance, how these together lead basically to identified optimal rotation time for maximizing biomass productions. And when we account also for the cost and the revenues of production, identify what is the rotation that maximize the profit. And we've been seeing through numerical simulation that at this density, the prawns are able to completely extirpate and block basically schistosomiasis transmission in rice paddies. What is we call a win-win solution, basically both for basically public health outcome and as a source of basically profit for small-scale type of aquaculture. With Nicholas Joanard and a team including Amir Sagi and Sean Coley, we also built up a commercial scale prawn hatchery that you can see here in this video. That is a little gem in Western Africa for the production of basically macrobrachium prawns here. And we have been also running a market analysis and conducted basically identify a business model to see how basically we can sustainably produce prawns, sells a part of the productions on the premium market in San Luis and in Dakar, and use the remaining part of the production to stock rice paddies and trying to control disease transmission. And just basically in November, we have been able to basically gather the first harvest and to sell it to a local restaurant in San Luis. Altogether, these basically make what we call the 4 pillars of wealth generating ecological based solutions, where we can basically sustain small scale aquaculture business integrated to agriculture, sustain food production and the production of proteins for nutrition, which are very important, foster ecological restorations of the native prawns, and also address major issues for public health. So let me conclude my talk by emphasizing basically only a couple of points. First of all, we believe it's really important to approach this problem with the system thinking approach. Being able to identify the nexus among the several different variables. There is a problem related to economic development, to nutrition, to health, to infectious disease, to the expansion of agriculture. And there are lots of linkages among them. And it's important to identify them in advance to avoid especially negative side effects and try at least to compensate or to identify solutions that are able to remove them. I think we need also to be bold and pursue win-win solutions that are able to target multiple sustainable development goals altogether, and basically try to avoid to work in silos. The problem of improving human health, improving development, and the problem of avoiding environmental degradations are too big to be addressed in isolations. And it's again, I want to emphasize how these linkages and feedbacks might actually provide very important levers to improve conservation and human health. I'm finishing. I want to acknowledge the really wide group of collaborators that made all this possible. This is truly a team effort, and I want to thank them all. And last but not least, I want to make a reference to a beautiful video that's been produced by the California Academy of Science, Biographics, in which you can find basically all the story that I told you with a lot more of detail. So you just need to Google in protected by prawns and you can find more information. Well, thank you very much for your attention, and I'm ready to move into the question and answer session.
Thank you so much, Giulio, for a fascinating conversation. We're now going to be joined by Professor Chirstina Hicks from Lancaster University to engage in a discussion on this topic.
Thank you, Chris, and thank you, Giulio. That was a really interesting talk on a really important and impactful study. I wonder if I could start off by just asking you to tell me a little bit about the context in Senegal where you're working, something about perhaps the livelihoods and the broader industries around the dam.
Absolutely. Thank you very much. This is a really important point. Schistosomiasis is a disease of poverty in general, and the context in which we have been working and operating is that basically of rural settings in pretty remote areas and subsistence economy. It's a type of livelihood that basically expose people to the pathogen that are embedded in the environment. The lack of access to clean water basically prevent any simple and immediate action to limit exposure to a parasite that is embedded in the environment. And so the remote places also, in addition to that, make access to affordable healthcare very difficult. And so all these together basically constitute what we often refer as disease-driven poverty traps, in which a component of the population is not actually able to basically exploit and leverage all the incredible positive effect of the construction of the dam, but to basically sustain most, of the cost that in this specific case are related to schistosomiasis transmission. I only want to emphasize, and just to be sure and to eliminate any doubt, the construction of the dam is truly really important. And the Diama Dam has been really effective both in preventing saltwater intrusion and at the same time to foster agriculture production, especially in the industrial level. So this is a really positive aspect, but there is this negative aspect that was connected with the expansion on habitat and the extirpation of important predators of the snail.
Thank you. It's good to get a better picture of the context. So I suppose related to that, prior to the dam, I was wondering, was there schistosomiasis present in the area? And the reason why I'm asking that is I was wondering if there are or were any local practices or perhaps behaviours that have developed to avoid the risk of infection.
Well, thank you for asking, Chirstina. Indeed, schistosomiasis was endemic in the area, but was only urinary schistosomiasis, one of the two major schistosomiasis form, that are led by two different parasites that are present in the area. So only urinary schistosomiasis was present and a really low endemic level. That was because in the absence of the dam, basically brackish water was able to invade during the drought season a good part of the lower basin of the Senegal River, and doing that controlling both the growth of special type of freshwater vegetation that are suitable habitat for the snails and the snail themselves. So schistosomiasis was a really low level and only urinary schistosomiasis. After the construction of the dam, there has been a ramp up in both urinary schistosomiasis and also intestinal schistosomiasis, which was definitely brought in during the construction of the dam and has become one of the two major parasites present there. In some of the villages where we've been working now, 99% of the school-aged children are infected with more than 80% of co-infection with both forms of schistosomiasis. About the second part of your question, that is how they can avoid, the only really way to avoid exposure to the risk would be to not to step into contaminated water, which, there is an understanding by the local population that there is a risk by doing that, but they don't really have any other alternative in the lack of access to pipe water or to water from wells. And for the daily chores and the kids, even just for playing in the water, during really hot season, they really have no alternative than accessing this water where the snails are present.
Thank you. The pairing of this freshwater prawn as a biological control and also linked to the aquaculture production sounds like a fantastic combination. I was wondering about the potential for scaling this out to other countries, even to other continents, and what the potential risks are associated with that. Say, for example, if the particular species of prawn is not endemic, or are there other alternatives available?
Well, this is a really good point. And we've been looking, scaling up is always a very challenging operation. The idea of integrating small-scale aquaculture with disease control is being done also in the effort to make it self-sustainable, so that farmers might embrace it to integrate this practice as a way basically of increasing their revenues. And so actively, proactively participating in these specific efforts. There are challenges, as always, especially in the area of biological control, in producing the right quantities, in developing sometimes also the capacity in country to run this type of operation. That's the reason why we've been building there a hatchery and try to train a new generations of aquaculturists that know the techniques and they can take on their own for their own business. Moving into other countries is certainly a possibility. We've been exploring both the opportunity of domestication of native prawns where present, which definitely would be the first way to go, even though domestication is a complex process and it takes years. And so it's something that can be accomplished only, with a sufficient time scale of the order, basically, of a decade. The alternative is to import basically species that has been already gone through a process of improvement in production. For instance, we could use, and we use in Senegal, the Macrobrachium rosenbergi, which is the Malaysian species of prawns, which is a very well established production protocol, as in fact is produced around the world. The problem here with the Malaysian is to avoid, of course, the invasion of an alien species. So in this specific case, we've been partnering with Amir Sagi from Ben-Gurion University, who developed a technique to produce monosex progeny, and specifically only male progeny. So we've been working in Senegal with these basically only male stocks. We've been running cross-fertilization experiment to check whether the Macrobrachium rosenbergi male can basically fertilize the Macrobrachium volenovi native African prawns, female. And we ran this experiment, we rule out this possibility that this happen, and so we safely stock the Macrobrachium rosenbergi, the alien species, that has the advantage of being highly productive. And last but not least, I want to mention also that prawns are just one potential agent of biological control. And we are exploring, we're interested to also find alliance to explore basically a range of other potential enemies of schistosomiasis, including potentially tilapia, the catfish, or the triploid sterile grass carp.
Thank you very much. It's been really interesting hearing about your fascinating and really important research. Thank you.
You're welcome. Thank you very much.
Great. Well, thank you so much again, Giulio, for your presentation. And thanks as well to you, Chirstina, for advancing the discussion by offering such terrific observations and questions. This is just a reminder, this is one of 3 spotlight videos focusing on the individual work of the speakers in this session, before we all come together in February in a live panel on the interdependence of human health, livelihoods, and aquatic social ecological systems. Please check the AAAS annual meeting website for the panel's date and time. Again, thank you, Giulio, and thank you, Chirstina, and you, the audience. We'll see you all live in February. Thanks. Goodbye. All right. So I think.
So let me stop recording.
I think that's a wrap for Giulio, unless anyone saw a problem.